Hello, calculus students. This is Miss LaGrew. Today I'm going to be focusing on a question from the AP Calculus exam, the AB exam from the year 2000. And this question has to do with differential equations and finding the particular solution at a specific initial condition. Here it says, consider the differential equation, and part A is what we're going to be focusing on, where it says find a solution y equals f of x to the differential equation satisfying f of 0 equals 1/2. Okay, so here what we're going to end up doing is, to start this problem off, is we have to separate the differential equation. We have to move all of the x terms to one side and all the y terms to the other. So in order to do that, we're going to multiply both sides, dx to the right side and e to the 2y to the left. When you do that, you get the following. E to the 2y dy equals 3x squared dx. Okay, and so here now, because we've separated correctly, we would get 1 point on the AP exam for separating correctly. And we can go ahead and start integrating both sides. Now, the integral on the left, e to the 2y dy, you're going to have to use u substitution there, okay? The integral of e to the x dx normally equals e to the x, right? But here in the exponent, we have 2y. It's more than just x. So we're going to let that be our u. U is going to equal 2y. And then we're going to take the derivative of u, which is du. Sorry, I meant to write du, not dy. Du equals 2dy, right? Notice that in the integral, there's only a dy, there isn't a 2dy, so what we're going to end up doing is we're going to isolate the dy by dividing by 2 to both sides. On the left side, what that means is that now we will have 1/2 du. These 2's are gone, and now dy equals 1/2 du. Okay, so when we go back into the integral and we substitute, we're going to bring that 1/2 in front of the integral symbol. We're going to substitute the 2y with a u, so we have 2 e to the u du. On the right side, we'll integrate using the reverse power rule. So 3x squared becomes 3x cubed over 3, which is just x cubed plus c. Okay, now we recall the integral of e to the u du is just equal to e to the u. So this will become 1/2 e to the u equals x cubed plus c. And because we've integrated correctly, here we would get a point each for the left integral and a point for the right integral. So total, that would be 3 points that we would have so far. And now what we're going to do is we're going to go back and resubstitute the u for the original 2y. So this will be 1/2 e to the 2y equals x cubed plus c. All right. Now we need to get the y by itself because it did ask for a solution y equals f of x, right? That's what it said at the top of the page. Yep, so we need to get the y by itself. So here we're going to multiply both sides by 2. All right, and that's going to go away. We're going to get e to the 2y equals 2x cubed plus, normally this would be 2c, but 2c would still just be a constant. So I'm just going to go ahead and put a c. If you want, you could put c with a subscript of a 1 there to differentiate between the two constants. Now we notice that 2y is still an exponent with the base of e. So in order to get rid of that e, we're going to take ln to both sides. Remember that the natural log of e is equal to 1. I'll write that here. Natural log of 1 is equal to 1. Now, when we take the natural log on both sides, this means on the entire quantity 2x cubed plus c. And here, what we're going to do is we're going to take this 2y using the laws. It means to bring it in front of the natural log. So, and ln of e is just 1. So really all we're going to be left with is 2y equals the natural log of the quantity 2x cubed plus c. All right, we're going to put that parenthesis around the entire thing. And then we're almost done getting the y by itself, but we still have that 2 there. So what we're going to do is we're going to divide both sides by 2. Okay, it's going to go away, leaving our y by itself. And then over here, we're going to have a 1/2 in front because dividing by 2 is like multiplying by 1/2. So this is going to become y equals 1/2 ln parentheses 2x cubed plus c. All right, so then there's our what we call our general solution because we have a plus c. Now what we need is not the general solution, we need the particular solution for the initial condition of f of 0 equals 1/2. So here we need to use f of 0 equals 1/2. And what that means, use this, is that we're going to plug in the initial condition back into this equation. So we're going to plug in 1/2 for y equals 1/2 the natural log to, I think, we're going to plug in 0 for x cubed plus c. Okay, simplify everything. Here we have 1/2 equals 1/2 the natural log of c, because 2 times 0 cubed is just 0. Excuse me. We're going to go ahead and multiply both sides of the equation by 2 to get rid of these 1/2s. Okay, here we go. This is going to give us 1 equals the natural log of c. Okay, and then in order to get rid of the natural log, we're going to use the base of e and take the base e to both sides. And we have e to the 1, which is just e, equals e to the ln of c, right? And using the rules of exponents and natural logs, anytime that we have e to the ln of something, it's going to allow us to just bring down that c constant. So then this is just going to tell us that c is equal to e. All right, and so then this is what we're going to end up plugging into the general solution to get our particular solution. So our particular solution, or the solution to this question, will be y equals, let's see, it started with 1/2 natural log of 2x cubed plus e. And this will be our answer for that question. And this is the end of this video. Hope it helped.